Today we're going to talk about data visualization in R. You're going to get stuck quite a bit. I use the tools in RStudio for that. Also use the question mark in the R. If you get an error message that you don't understand, try adding R to that in a search query or just searching that directly. And use the cheat sheets. That is, the data visualization is one of them, but there are in RStudio, here's RStudio is open, and I can go to cheat sheets, and there's a list of cheat sheets that is really informative lists of different possible functions that you can use within any of these sort of libraries. Many libraries have generated those, and you should be using those for your workflow. I printed one out for my wall. Keep it handy. Know about your helpful resources around. There are people who, for some reason, incredibly talented people who scan the web and help people with their problems. Those of us who are learning can get support from those people who are already very skilled. Two of them are Hadley Wickham and Yihui Shi. These are probably the most prolific R script or R library writers. They've generated a lot of very useful things, and they often answer people's questions. They have blogs, they have lots of libraries that they've written about, and you can learn more about them. I recommend doing that. So getting started for today, of course, the first thing we need to do is get our data into the R language, into the script, so that we can work with it. So we're going to go participants data, and then use the read CSV function. So I'm going to open, here I am in RStudio. I'm going to open a new R script, and I'm going to call this, I'm going to say load data, participants data. And that runs, and now participants data is loaded. As you recall, you may have a slightly different data set on your side, but there it is. That's your data set with your information. Keep your data in the same folder structure as the R project and add or below the level of R project. So here's my filing structure, and I have the R project here. And the R project is where all the folders are. So data visualization is a subfolder of R project, but nothing that I want to access with the R project is elsewhere. It's not on my desktop. It's not in another folder. It's somewhere at or below the level of the R project. You can see here when I go to Files, in this portion of RStudio, then I can see all the same files here that are related to the R project. So there are many different ways to do things in R. There's no one correct way. Generally, there are many ways. And you can use base R to make a plot. So we can use the plot function to plot your data. And when you run that, you'll get a nice plot, a bar plot, yes and no, academic parents. So creating a box plot in base R, what we're going to do is, you can see the box plot already, we're going to create a box plot with the same plot function by providing a factor and some continuous data. So academic parents and days to email response. And I'll go to my folder. I'm going to save this. Save R, so you all can have access to that. And we get these box plots. There are many different libraries that we can use. ggplot is my preferred library. ggplot2. It implements something called the grammar of graphics to design and build graphs. You can do more and you can do it faster if you learn one system. So you should know how to do some things in base R, but generally using this elegant system that generates really, really nice graphs is going to be more efficient for you. And you can learn about ggplot2, the layered grammar of graphics, again from Hadley Wickham and his group. The paper is here, linked here. Please copy or get it from the HTML file. We're going to use an example from your data, the participants' data, and we're going to ask, first of all, of course, for the library ggplot2, and then ggplot that data, which is participants data. And then we're going to give an argument AES, aesthetics. And what kind of aesthetics should it have? So first it needs to know the data, and then the aesthetics. And the aesthetics are X and Y. So what's going to be on the X-axis, what's on the Y-axis, and what sort of plot would you like to have? That's the geom function. So I'm going to go ahead and plot that. Scatter plot of the days to email response as a function of the letters in your first name. If you want to know how all these pieces fit together, you want to learn more in depth on this stuff, then please check it out. Again, R for DS. That's Hadley's group in New Zealand, Hadley Wickham. Okay, what if we want to add color and size to the plot? Well, again, in this AES argument, so remember the first argument is the data. The next argument here is the aesthetics, and we said X and Y. We can add some more arguments here. We say, let's say we want it to have a color according to this factor, and we want it to have a size according to, remember, academic parents is yes and no. Working hours per day is the size, and we're going to plot that as a geom point. And here you can see, you get a nice plot. Now the data points are in the same locations, but we can see the size is different according to the working hours, and the colors are different according to academic parents. There's some overlap with some of these points. And that's how you add colors and size. That's how you adjust the aesthetics of the plot. I'd invite you now to take a break and make some more graphs. So we're going to take an example from Anderson's IRIS dataset. If you want to know about IRIS, that is not a dataset that we've loaded, but it's one that comes with R. Just go ahead and question mark IRIS to find out more. We're going to give this, the data is IRIS. We're going to give the aesthetics X as sepal length, Y as petal length. Those are variables within the IRIS dataset. Color will be species and size will be petal width. And again, we're going to plot that as a scatter plot. And then if we run that, it's a scatter plot of iris petal length as a function of the sepal length with colors representing iris species and petal width as bubble sizes. Now let's use the diamonds data and plot the price. So ggplot, what you can learn here is ggplot also accepts other formulas such as log. You can do question mark log to find out what log does. So we're going to do ggplot. The data, again, is this new data set, diamonds, like iris. It comes with R. Just type question mark diamonds to find out about that. So ggplot function. And the AES here is going to be, the aesthetics are going to be X is carat and Y is price. That's the carat of the diamond and the price of the diamond. Alpha, that's the opacity of the plot, 0.2, just so we can see everything. And then I'm going to plot this as a geom point again. Now if we run that, diamonds is a big data set, so it takes a bit to run. It may take a bit of time on your machine. We get this plot. But we could also do, again, accepts these arguments such as log. We can also do Y as log price. So let's try that. We run this again. Now we run that. And the Y-axis will be different in this case. It may take a minute to run, because Y is now the logarithmic scale of price instead of price. Okay, what I want to do now is take a small piece of the diamonds data by using the dplyr package as we did yesterday. And I'm going to use a function called top_n. So that takes the top of a data set by n, that is how many rows you want. So I'm going to take the first 100 rows of the diamonds data, and I'm going to plot with different colors with the color of the diamond. That's another piece of data that we have about the diamonds. So I'm going to create this data set d small, and then I'm going to have d small. First I need to load the dplyr library. I'm going to run all of this. So I run the dplyr library. I'm going to create d small using dplyr top_n. And we can also plot with different shapes. We use cut as the option for the different shapes. We're advised that this is not a great idea using shapes for an ordinal variable, but just as an example, shapes are possible. Apparently not advisable. Another thing you can do is set parameters. So there's the I function, which is interpretation, so inhibit interpretation. So instead of, because normally we assign aesthetics, within aesthetics we assign things. X, for example, is caret, a variable within the data set. Price is, Y is price, also a variable. And alpha, that would be the opacity of the things that are shown on the graph, would also refer generally to a variable, but here we can say I, that is to inhibit interpretation, and just use 0.1. So everything gets a 0.1 alpha. And the same for color. It doesn't have to be a variable in this case. I just refer to the color blue. I want the whole thing to be blue. Don't interpret this as anything, just plot it as blue, and I use geom point here. Again, we're using diamonds data, so it takes some time to plot. Here we're going to plot again with data diamonds, and caret and price is the X and Y, a different alpha, slightly darker, and the color green, just as an example to show that what's adjustable here, which kinds of things you can adjust in the parameters. You can adjust lots of things, and you can take control. Using the geom, so we tried geom point so far. Using the geom, different types of plots can be given. So there's all kinds of different options. Let's try a few. So again, we're going to use that d small data. That's the first 100 rows of diamonds. And X will be caret, Y price. Again, we're going to use both geom point and geom smooth. So let's see how that looks. Chooses a method for us. So it's using the method los and the formula x, y, tilde x. But there are a number of different options. We could run this only with point data. We could run this with only smooth data. We could run this with a line, maybe. Okay, or we could run this with, what did we have before? Point line, smooth. That smooth function selects the smoothing method based on the data. So we can use method as an argument in the smooth function to specify the smoothing method that we would like. So let's try both of these. First of all, the one I think we just ran, small caret price geom point geom smooth, that's the one we just ran. So we're just going to add method equals GLM and see what happens. So we're going to use the generalized linear model. Method equals GLM. And if you want to learn more about options in smooth, you can enter question mark geom smooth down here, and then you get the help file, and it tells us the types of arguments that it will accept. I recommend trying the various smoothing options and see how those function. So we can use geom box plot as one of the geoms for creating, of course, box plots. I do that quite a bit. So we're going to use the same style here and just add a geom box plot at the end. So we can even do that for the stuff we had here. Just to save some time, geom box plot. So I've got the plus here after the last argument. It's a lot like the Magritter, if you remember the Magritter package where you can pass the argument on. Now geom box plot just accepts that whatever's been called, the data set and the aesthetics are going to pass to geom box plot. So then I can just run, and then we can add jitter points with geom jitter, and we would just add plus geom jitter here. We can combine aesthetics. We can combine geoms. So now we've got a jitter plot on top. I think we wanted to use diamonds. It's going to take a while to run because it's a big data set. And if we wanted to, we could add an alpha. So here, this is quite crowded. We can't really see the box plots anymore. If we want to see the points and the box plot, then we can add an alpha. We talked about this before, where we can use the inhibit or inhibit interpretation and then add an alpha to the thing. So I can just add. Now you can see the box plot somewhat. I mean, I guess we would turn that alpha down some more to get a perfect plot. And those are the options. So you've got your box plots, your crowded box plots, and then your, on the right-hand side here, a little bit more visible, smoky mess of data. So histograms, we do quite a bit of histograms in our work. When we're talking about probability densities, we use histograms all the time. So let's try a density plot. Yeah, the first thing we're going to do is just plot. Well, we don't need to select everything, but we just plot a simple geom density of diamonds data, just of the variable carat. So that's the density of carat, and then we can probably I wanted to say fill here. Yeah, the reason I did that was to show that you can see through these densities, so you can still get a sense for the rest of the data if you use an alpha. That's why I said an alpha there. So we're going to use factor to subset data within ggplot. So let's say, for example, I wanted to run a, now I'm going to use a different data set, M miles per gallon. Check that out again, MPG, by doing question mark MPG. I'm going to use that as the data. The aesthetics are going to be displacement and highway. I think that's highway miles. And the color will be cylinders. And we're going to use both geom point and geom smooth, so 2 geoms. And the method will be regular regression. And then we want to do the same kind of plot. But the thing we're going to do differently is to use color not just as cylinders, but factor cylinders. Cylinders, remember, it's numeric. So I'm just going to add factor here. Make sure you've got enough use. You can see a little highlight with the parentheses. So there need to be parentheses closing everything. If I were a lady, I would participate regularly in their work. Here's some examples of something they've come up with called slow ggplotting for the aesthetics in ggplot. So what they like is to add lines for every new addition to their ggplot. And this is, I think it's really nice way to learn about using R, and a nice way to have clean code so you can follow it easily later. But it does get quite long. So they use functions multiple times. Instead of putting everything at once in the aesthetics, they rename aesthetics every time. And also they advocate for using this mark in the code. So instead of writing just ggplot, I would write ggplot2, because that's the library, and then I would write the function. This way you always know where this function comes from. So you would do that for every function in the code. And they write out all the arguments so they don't take shortcuts. So they always put, for example, you'll notice I go back and forth, but they always put the x there. You don't have to. You don't have to say x equals. You could just write this argument, and the function knows that the first argument that comes is for x. So they wouldn't, but they would in this slow ggplotting, you wouldn't do that. You wouldn't write this. You would write x equals to make it clear what it is that you're referring to. You can check out Eva Mary's stuff on this for the slow ggplotting. There's some more information as well. So here's an example of not slow. We did this before, but with some more, adding some more things. So what you've learned so far is that you can call ggplot on a data set with or without saying data equals here. We can just say ggplot empty cars. It knows the first argument is data. And then AES, and AES knows that the first arguments are X and Y. I didn't even have to put the Y here. It would just know that that's X and Y. And then colors equals gear. I didn't even have to put, and I did have to put colors there. And then I called geom point. So I want it to be a point thing. And then I add a title, and I add some labels to the X and Y. So let's try that. So you can see my title is here, and the X label is here, the X label. Down here on the X-axis, the Y label, because I added labs, is here on the Y-axis, and legend title is here above the legend that describes the data. But a slow version of the same plot would put each of the arguments on their own line. So you would say ggplot data equals cars, AES X equals MPG, and then add the X label, and then Y, and then add the Y label, one line at a time. And this, of course, results in the same plot. Again, I'm just hitting Command Return on my Mac, or you can hit run. All you have to do is just click anywhere in the plot and then run. If you click on a specific thing, so if I just click here on empty cars, for example, then it will run and get empty cars. I get the whole empty cars data. If I click anywhere here without selecting and then just hit run, then it will create the plot. So now I'm going to use dplyr, ggplot, and reshape2 to create a geom tile. So the first thing I want to do, this is just to play around with correlations. I'm going to create a data set called part data, so just part of participants' data, by selecting only those variables that are numeric. And I'm using the dplyr package, so the dplyr library, and a function called selectIf. And it will select if participants' data meets a certain argument, and my argument is the variables are numeric. So it's going to exclude things like your country of origin, your country of research, whether or not you have academic parents, all of these things which are not numeric. So I'm selecting part data and running that. You can see it's only numbers here. So it's only the things from your data set which are numeric. And now I'm going to run to create another object called cormat. I'm going to round a correlated set of a correlation matrix of participants' data. Yeah, round is one here refers to how many digits I should round to. So cormat, if I now select cormat and then run here, or click command return, no, it does the same thing. It's now created a correlation matrix. So every variable on the as a row and of course as a column, and then the correlation, perfect correlation between batch and batch because they are the same. Remember, now I'm going to melt that data set by using melt, which is from the reshape 2 package. So I'm going to melt that correlated data so that it becomes something that I can work with. Now I have 2 variables here, 2 variable names and their shared value in 3 columns. And finally, what I want to do is use ggplot on that melted data with the x as the first variable, y as the second variable, and the value as the fill. And I'm going to do that as a geom tile. And now you can see that I can visualize the correlation matrix. So whereas earlier we had numbers, now we just see some nice shapes and we can see how strong the correlations are between different. We want to export this nice figure that we've made. We can use a function called PNG. And I invite you to read more about PNG by doing PNG. You should check with your journal what kind of outputs they expect. But a PNG is generally expected. You could also do a JPEG or a PDF. I think that might be another PDF. It's also possible. From GR devices, you can export a PDF. Okay, what I'm going to do is I'm going to tell the interface that I'm going to create a file, and the file is going to be called quartile PNG. I'm going to specify the width, units, and the resolution. The nominal resolution in PPI pixels per inch. I'm going to call ggplot again on that same data. Yeah, I take a few more steps. I want to pretty it up. So you can see here that I add to the geom tile, I add a theme argument, and then I create the element text angle at 45 degrees. And then HJust just acts as tick marks here. And then I turn dev off, that's for the PNG. So I'm turning it off, it means that's all I wanted in my plot. And please export that. And now, when I look in files, and I find my teaching R project, then I'll also find in that same level, quartile.png. Again, check with your journal about the size and the resolution, and check out PDF. Yeah, we did that. Now, I want to show you some really exciting stuff, ggAnimate, so how to make moving plots. So we're going to run these here. It's ggplot, data source dozen is the data set that comes from this group, data source, from this library. And we're using the library ggAnimate. So we need to run both of those, of course, to load the libraries. If they don't run, if something goes wrong, it means you need to install the package, probably. So we're going to run the ggplot function on this data. And for the aesthetics, we're going to say x is x and y is y. That's built into the data source data. Those are variables there. We're going to do geom_point theme minimal. That means the background will be without all this gray background. And then I'm going to call something called transition states. We can see how transition states work. And then ease AES. So I'm going to ease the process of the aesthetics with a function, with a part of this functional option of this function called cubic in out. and it takes some time to render. That'll be easiest to see here in the slide. These data have the same, those numbers are all the same for these data. That's why Autodesk brings this to our attention to just open up a conversation about data visualization. So now we're going to run ggAnimate on diamonds and the caret of the diamonds. We're going to use, for this, we're going to use the tidyverse ggplot2 and ggAnimate. And we're going to run ggplot on the D small data because diamonds is quite large, and as you saw, it takes a while to run an animation plot. We're going to use caret and price and also color, the color of the diamond for the color of the plot. We're going to plot it as a geom line. We're going to use the transition reveal function again from ggAnimate on caret, so it's going to reveal to us the caret as it plots. I'm going to use a different kind of ease AES, which is linear. You could play around with the different options for ease AES. And I'm going to add a label, not just a label title, but also this frame along argument is going to follow the transition reveal and give me the number for caret as the transition reveal moves along. That's a little bit advanced. Here you can see that running here. I've run it earlier in my R because it takes quite a while to render. Even with the diamond small, hopefully your machine is a little bit faster than mine. Just be patient and as you're playing around with these animation options. So it's time for you to test your new skills. Create some plots, vary those samples that you used in the data to check those plots, maybe even use factors to break it down. Save your most interesting figure and share it with us tomorrow. And this is your turn to perform. So I want you to play and go dig deeper than we just did in these slides together. Import some data, find some data somewhere, use your own data, display them in an interactive plot, play around with design, export your most interesting figure and share it with us. Go through these slides just as a backup, but you have all the text, so play around with these, change the parts and make it your own. I'm looking forward to see what you come up with and talk to you tomorrow.